section 11.4, and we're talking about least common multiple and least common denominator. Okay, so we're using the same method. So find the sum or difference. This is from the last lesson. So here we have the common denominator x minus 1. So now we just have to combine the numerators. Okay, so this minus means minus this whole numerator over here. So it's going to be minus x and then minus 5 right there. Okay, so distribute the negative through and we get minus x minus 5, so 3x minus x is going to be 2x. Okay, 2x minus 5 over x minus 1. Don't make the algebra 1a error or the pre-algebra error and cancel those x's right there. You can't. If there's ever a plus or minus next to them, you can't cancel it unless it's the same thing. If it was 2x minus 5 over 2x minus 5. Or x minus 1 over x minus 1. So you can't cancel it. That's your answer right there. Okay? All right, do the same with this one. You have to get common denominators, which is 12. So we'll multiply this one by 3 over 3 and this one by 2 over 2. That way I get 3 times 4, which is 12. Here I'll get 6 times 2, which is 12. So 3 times 1 is 3. 5 times 2 is 10. So we get 3 twelfths plus 10 twelfths. And when we add those together, we get 13 twelfths. And it's better to leave it as an improper fraction, but some people are so inclined, they just have to put it as a mixed number. I don't care. It doesn't matter to me, and I'm sure if whatever your teacher, it doesn't matter to them, but you'll find this one becomes more friendly as we get moving along. Well, it just depends on the situation. All right, so steps to find the least common multiple. Okay, so write the prime factorization of each number using exponents, and sometimes they're polynomials, you guys. So we'll talk about that as we get a little bit more deeper in this problem here. So remember factor trees right here, and then what you do is you circle the greatest power of each prime factor. And then your least common multiple is the product. You multiply all of those circled numbers that you did. Now there's other ways to do it, you guys, but when you're talking about polynomials, this way is the best way to do it, you guys. So I'm going to teach it this way with regular numbers, you guys. And you've done least common multiples before, you guys, but you probably didn't do this method. And this method will help us with the polynomials. You'll see why in just a minute, you guys. So find the least common multiple of 12 and 30. Okay, so the first step is to find the factor tree. So use find the prime factorization. So 12 is 4 times 3. 3 is prime. 4 breaks down to 2 times 2. And over here, 30 is 6 times 5. And 6 breaks down to 2 times 3. Okay, 5's prime. So 12 equals 2 times 2, which is 2 squared. So it says using exponents, so that's why I wrote 2 squared instead of 2 times 2. And then times this 3 right here. And then 30 is 2 times 3 times 5 right there. Okay, 2 times 3 times 5. Okay, so now we're going to circle the greatest power of each prime factor. Okay, so here's all the prime factors in 12 and 15. I see some 2's, I see some 3's, I see some 2's and 3's and 5's. So we're going to circle the greatest power of each prime factor. So this is the biggest power of 2's. Okay, and these guys are tied for how many 3's there are. So just circle one of them, you guys. But you got to circle every one. So I got to circle the 5 also. So there we go. Circled the 2 squared. That's the biggest power of 2's. And I circled that 3. I could have circled that 3, but just circle one of them. And then the 5 is included also. So the greatest power of every prime factor. Okay, and then the least common multiple is you multiply all of those. So 2 squared times 3. 2 squared is 4. 4 times 3 is 12. And then 12 times that 5 is 60. Okay, let's try it again. Between 16 and 20. Okay, so the first thing is to get the prime factorization using exponents. So here's 16. It's 2 to the 4th. And 20 is 2 squared times 5. It's 4 times 5, but it's 2 times 2 times 5, which is 2 squared times 5. Okay, so I see some 2's and 5's. I'm going to take the biggest power of 2's, which is this one, and the biggest power of 5's, which is that one, and then multiply them. Okay, so circle the biggest power of each prime factor, and then multiply those. So 2 to the 4th is 16. Well, remember, I got 2 to the 4th right here, which came from this 16 right here. And then 16 times 5 is 80. Okay? All right, let's try some with some polynomials. Okay, so here what you got to do first is you have to first factor these polynomials. So what factors of 9 add to 6? 3 and 3. So this is x plus 3 times x plus 3. Or x plus 3 squared. Okay? Here, factors of negative 6 that add to this positive 1 are positive 3 and negative 2. So there they are factored right there. Okay, and then your least common multiple is the product, which means multiply, of the greatest power of each factor. So I see some x plus 3's and I see an x minus 2. This is the biggest group of x plus 3's, so it's going to have this one and it's going to have this x minus 2. So the least common multiple is going to be x plus 3 squared times x minus 2, the greatest power of each factor. All right, find the least common denominator of the rational expressions, LCD. It's the same method, you guys, except we're just looking at the denominator. So I don't care what's happening in the numerators, not today. That's in the next lesson, you guys. So let's get the prime factorization of 4 and the prime factorization of 10. 4 is 2 times 2, or 2 squared, okay? So oops, I thought I wrote it down. There it is right there. Okay, so here's 4. 4 is 2 squared, and there's r cubed. 10 is 2 times 5 and r squared. Okay, so least common multiple is the same as least common denominator. It's the least common multiple of the denominators. That's what least common denominator is. Okay, so I'm looking for the most of every factor. Okay, so I see some 2's, I see some r's, I see some 2's again, a 5 and some r's. The biggest group of 2's is this one. The biggest group of 5's is this one, and the biggest group of r's is this one. So I'm going to do 2 squared times 5 times 3. 2 squared is 4. 4 times 5 is 20. And so it's 20r cubed. Okay? All right, same thing. Let's just get the prime factorization of 9 and 6. So 9 is 3 squared, and 6 is 2 times 3. Okay? So remember, most of every factor. So the biggest group of 3's, the biggest group of 2's, and the biggest group of x's. Okay? So my LCD is going to end up becoming 18x to the 4th. All right? Okay, let's try this one. Okay, we're just looking at the denominators, you guys. The lowest common denominator, least common denominator, okay? This one's x minus 8. I can't do anything with that. This one's x plus 1. I can't do anything with that. So it's just most of every factor. Well, I see an x minus 8 and I see an x plus 1. It's got to have them both. That's my common denominator, okay? All right, how about this guy right here? Okay, let's factor this. This one's already factored, so I bet this one has an x minus 3 in it. So factors of negative 6 that add to negative 1 are negative 3 and positive 2. So x minus 3, x plus 2. Okay, most every. Okay, most every. So I'm going to see some x minus 3's. The biggest group of x minus 3's comes from this one. And then the x plus 2's right there. Okay. All right, I think I have one more. Yeah, I do. Okay, so here we go. We're just looking at the denominators today. Tomorrow we'll deal with the numerators. Here we're just looking for the least common denominator, okay? So this factors to x plus 4, x minus 4. This one, factors of 16 that add to negative 8 are negative 4 times negative 4, so x minus 4 squared, okay? So there's the denominators right there, most every, okay? So I see some x plus 4's, x minus 4's, but I'm going to take this one because that's the most of the x minus 4's, okay? So my LCD is x minus 4 squared and then x plus 4. All right, you guys, if you're in my class, I'm going to assign you that for your homework.